Hello, this is Matt from Ace Appliance in Toledo, Ohio. Welcome back to another in-home diagnostic video brought to you by ApplianceVideo.com. The tools that were used on this repair, just a flathead screwdriver. This is a tack puller. You can actually substitute it for just another larger flathead screwdriver, would work just the same. A volt-ohm meter, a drill, and a circuit analyzer. That's just to check the polarity of the outlet. You can get them at pretty much any hardware store for about $6 to $8. Okay, well, what we have is a Whirlpool side-by-side refrigerator here. The customer's complaint is it is making ice. The ice cubes are full size, but we're not getting any water whatsoever through the dispenser. So what we're going to do is get access to our inlet valve on the back here, and we're going to depress the paddle in the front and actually check voltage to the valve to see if we are getting power to the valve, and that will kind of give us some direction on where we need to go here. So we're going to take the 1/4 inch screw off on the panel here. So peel it back to get access to our valve, and then we got two 1/4 inch screws here that hold the valve bracket in place. So we've got this line here on the right, which is the yellow solenoid. That's going to feed this line right here up to the ice maker. So we're looking at the opposite side here, which is the green solenoid, and that's the one that we're going to want to check to see if it's getting voltage when we press the paddle. So we'll take the connector off, set our meter to volts, shove them in the leads there. We've actually got 120 volts coming to the valve right now, which is not what we should typically have. We shouldn't have any voltage at the valve unless we're calling for water. We may have some kind of an electrical issue up front. What I'm going to do is set the meter back over to ohms. I'm going to check continuity on the valve itself. We got 268 ohms, which should be within range. So we are going to go up front and check some voltage up there, check the switch, see if we got something going on up front there. Okay, what we're going to do, first thing I did was I checked the polarity on the actual wall outlet. What I've got is just something like this, to where you just plug it into the wall outlet and these lights will light up and let you know if your polarity is correct. Well, I've checked the valve, and because we have the 120 volts constant at the valve, what we're doing is we trace the purple line off the valve, and that comes into the main control board here. So we're either going to be looking at a stuck relay on the main control board, or we're going to have a bad display panel, possibly a bad micro switch. But we're just going to pop the cover on the main board here. The unit is unplugged, and just look to see if there's anything that rings a bell, anything out of the ordinary. Just going to kind of disconnect it and kind of just get a look at our connectors here. It's P3 and P4, which is all the wiring that's going to go down that way. And nothing really looks out of the ordinary. Don't see any visual burn spots. So I'm just going to go ahead and reconnect it, plug the unit back in, and we're going to check voltage again just to see if it was an issue with a connection. So we're just going to check one more time voltage. We still have 120 volts to this connector. So we're still in the same boat, more or less. We're going to go ahead and disconnect power to the main display board. Okay, we're going to go ahead and disconnect power to the display board. Leave our other connector still intact, the connector with the purple wire on it. And we're going to go ahead and plug the unit back in and check voltage one more time. And we are just checking the voltage again, and we still have 120 to the valve, so that did not rectify our issue. the next thing that we're going to check here is we're going to get some access to the little micro switch that you have mounted back up underneath there, just to see if the contacts may be stuck on that. So to get access to it, kind of take your fingers, pull down along the base, lift up on the cover. It's just got tabs along the side there. And what I use is a little tack puller. You could use a flathead, and you just right up under the underside on each corner, you see a little bit of an indent. Just sort of gently pop it, and then you've got 3 tabs under here. What you want to use a thin flathead screwdriver and gently release the tabs. Lift up off these 3 hinges, and you've got a little connector on the back side there. Press the tab, pull it off. Okay, well, we've got access to our micro switch right here that we want to ohm out. There's a little white tab. Just slide that back. The switch will slip out of its mounting position. Okay, now that we have the switch, we're going to go ahead and pull the connector off. Kind of check, make sure there's nothing black on the terminals, anything like that. Okay, so what we're going to want to do is just ohm the switch out. Right there, pressing this little button in is actually opening and closing the switch. So we're going to take a meter, we'll set it to an ohm setting. And without depressing the switch, you should not have any continuity, which we do not. And when we press the button in, we do get a reading through it. Just 0 resistance, but you see the meter kind of bouncing. So that lets us know that it's opening and closing. So the micro switch is not our problem. Alright, we're just going to go ahead and put it all back together now. Reconnect the micro switch, and you want the push button facing inwards. Just going to slide it back onto the mounting tabs, and it'll snap into place. You can give it a quick test, make sure it's hitting the switch there. I'm going to go ahead and put our display board back on, hook the connector up. Push it in the center to snap the center tabs in. Push it in the bottom to snap the bottom tabs on. Got your cover plate, hang up over the top. Push it at the bottom to snap it in. Your little water trap. And it's back together. Okay, well at this point, now that we've checked that micro switch, what we're more or less down to is either an issue with a short in the display board sending voltage down to the valve, or an issue with the main control board. The relay is sticking on the board. So what we're going to do is, at this point, because it is a short, we're going to order in both boards. We're going to start with the main control board and also the inlet valve, because the inlet valve, the fact that it has 120 volts to it, actually it should be pushing water through the valve at all times with the readings that we're getting. So we are going to replace the inlet valve in the main control board first, and possibly the display board. Thank you for watching another quality video from ApplianceVideo.com.